Greetings and welcome, friends. Mr. Waddy here. We are continuing our investigation of writing equations of parallel and perpendicular lines. Today, we are specifically looking at perpendicular lines. Now, perpendicular lines are two lines in the same plane that intersect to form right angles. All right, and a right angle has a measure of 90-degree angle. Okay, so here's a right angle. You can actually label right angles on a sketch by putting a little angle mark of a box in the corner or the intersection of those edges, lines, rays, whatever we happen to have geometrically drawn. So those are what perpendicular lines are, and it says non-vertical lines are perpendicular if and only if their slopes are negative reciprocals. All right, so I'm going to write opposite flips of each other. All right, sometimes for reciprocals I say refliprocals. Am I right? So for instance, a reciprocal, if I have 1/2, the reciprocal of 1/2 is 2/1. If I have 3/7, the reciprocal of 3/7 is 7/3. If I have, let's say, 5, what's the reciprocal of 5? How do I flip 5? Yeah, 1/5. Because 5, I could have imagined as being 5/1. All right, and they're also opposite or negative of each other. So if this one's positive, this one's negative. If this one's negative, this one's positive. If this one's positive, this one's negative. That's how these things relate. And then we also had this other fact that vertical lines are perpendicular to horizontal lines. So notice like the y-axis is perpendicular to the x-axis. There's a 90-degree angle right there, and that is true for all lines that are parallel to the y-axis. They are going to be perpendicular to the x-axis, and all of the lines that are parallel to the x-axis. Right? So let's use this fact that perpendicular lines have slopes that are opposite reciprocals, and we'll use this fact to find equations of lines and to become better detectives in solving the mysteries of lines when given a handful of clues. So it says this, example 4, write an equation of a line that passes through a point and is perpendicular to y equals 1/2 x plus 3. So let me I'll just throw a little graph of this up here real quick. Why not, shall we? Let's see. -3, 1 is the point. Negativo 3,1. Bam. There's -3, 1 showing up in a vibrant red color. Lovely. And y equals 1/2 x plus 3. Question, what is the slope of this line, friends? Y equals 1/2 x plus 3. What's its slope? 1/2. What's its y-intercept? 3. Yeah, so y equals 1/2 x plus 3. There we go. Now, I'm not looking for a line that is parallel to this blue line. I'm looking for a line that is perpendicular to this blue line. So that's what I'm shooting for, okay? And since the slope of the line they gave us, slope 1, is equal to 1/2. What do you think the slope of our line is going to be if it's perpendicular to it? What is the opposite flip of 1/2? Yeah, 2/1. And instead of positive, this will be negative. Right? You could also just write that as -2 as well. So all I'm doing that's different today is I'm getting a different type of slope from the equation that was given to me. But the rest of my work is actually going to be the same, so it's going to be excellent rehearsal of our skill set. So I highly recommend, since I have slope and a point and a slope, that I use the point-slope form, y minus y1 equals m parentheses x minus x1, my friends. Bam! Look at that. Beautiful. So let's plug it in. Plug it in. So y minus, well, that was a crazy y. That was a little wild for a Wednesday here, friends. Y minus y1, so that's y minus 1, equals m, which is negative 2, parentheses x minus x1, and let's see, x minus a negative 3 will be plus 3. So here's my equation in point-slope form. That's technically sufficient to leave it in that form. All right, but we'll also practice just putting it into sloppy intercept form. Now, it is possible that I could, actually maybe it is possible that I could have the same y-intercept as this equation and still have a line that is perpendicular. In this case, it's not going to be the outcome. That would be a rare occurrence, but I just want to point that out, that perpendicular lines can have the same y-intercept as the line that we were given, whereas parallel lines can't, because if they have parallel lines having the same slope, if they have the same slope and the same y-intercept, we're talking about the same line, right? That wouldn't be parallel. Those would be coincident lines. All right, so here's my line, right? So I was talking through that whole experience, but we are so good at converting from point slope to slope intercept form. It's like Bumblebee going from car form to, like, I don't know, pseudo man mech form, whatever you'd want to call it. And we're so good at it. We're just, right? We can just change forms all the time. I'll just have to have someone add the sound effect in post. But I think I nailed it, to be honest. So y equals negative 2x minus 5. Let's graph that. Over here, y equals negative 2x. Guys, look at y equals negative 2x is perpendicular to the blue line. And like I was saying earlier, it could have the same y-intercept and still be perpendicular, right? But my y-intercept, I want the one that's going to result in it passing through that point, which we claim was negative 5. Nailed it! Look at that. Thing of beauty. Thing of beauty. And yet the y-intercept does in fact happen to be down at negative 5. And so now we have more ways of discovering lines, right? We found the line that was perpendicular that passed through that red point. Wow. Ooh. Guys, I think if I just went forever here, it would just keep going forever. Isn't that weird? Should we just spend the rest of class zooming in on this red dot? All right, yeah, you're probably right. Okay, yeah, you're probably right. That's probably not the best use of time. Let's do another example though. Let's do problem 4, which is from the monitoring progress. So same type, but I think these are worth rehearsing a little bit. There we go. So problem 4, you guys can find that. Let me refresh this. Yeah, I'll reload because I don't want to be all zoomed in on that. And for problem 4, I've got the point negative 3, 5. Was that the one that I was at earlier? No. That is not. Nope. It doesn't understand what decimal point negative 3, comma 5 is. There we go. So negative 3, 5. And the equation they gave us was y equals negative 3x minus 1. Y equals negative 3x. Come on. Come on, Mr. Waddy. Negative 3x minus 1. So there's our equation. Yes, I'm sure we could imagine and even find the equation parallel to this blue line. It would just have the same slope, right? But I'm looking for a line perpendicular, right? That's going to be a 90-degree angle, a right angle to that blue line. And so in order to do that, I'm going to need this line's slope. What is the slope of the line they gave us? Yeah. And what is the negative reciprocal, the opposite reciprocal of that number? Positive. Ooh, well, it's positive. And I've got to flip this. Yeah, 1/3. Yeah, it's sometimes tricky for those whole numbers. So just imagine them as being over 1, and it'll make it a little easier. So I've got my slope. I've got my y-intercept. Or sorry, no, I do not have my y-intercept. I have a point. How do I know, by the way, that that isn't a y-intercept? You guys remember? How can I recognize a y-intercept just by looking at a point? A y-intercept has a 0 for its x coordinate, and this one doesn't. But that's fine. That's fine. So let's plug this into point slope form. Y minus 5 equals 1/3 parentheses x plus 3. Remember, my friends, that this is the opposite and the opposite, right? Opposite of both of those, right? So that way you don't kind of mix up your double negatives or things of that sort. So let's do some distributing here. Uh-oh. What is 1/3 of 3? Ooh, no? Or I could ask it, what is 3 divided by 3? Yep, plain old 1. Yep. 1/3 times a third would be 1/9, though.
Oh, yeah.
Yep. And how do I get y by itself, friends? Well, y just needs some space right now. Add 5 to both sides. Yeah, there we go. That's what when my kids get upset, they're like, I need some space. It's like, all right, we'll give you space. Or like, we'll tell their brothers to stay away. Yeah, y just needs some space right now. It's like, okay, we'll let you have your space, y. So y equals 1/3 x plus 6. My claim is that it is perpendicular to the line given and passes through the point they wanted. Let's graph it, friends. Y equals 1/3 x plus 6. Y. Nope, that's a 1. Y equals 1/3. Nope, not. Meh. 1/3 x. Hey, look it. 1/3 x is already perpendicular. If I hit the plus 6, bam! Wow! Did you see that? Nothing but net. Nothing but net. That was amazing. Like, wow. Of the infinitely many lines on the coordinate plane, I found the only one that fulfilled both of those requirements. It's just amazing. It's just amazing. All right, here, let's do this real world problem. Okay, this is an interesting little problem. Example 5. And I think we'll end on this, and then you guys will have some time for some class questing. All right, so it's a problem about a helicopter, and it's like flying, and it's going. Man, my sound effects are so amazing. You guys, you were probably thinking that I had a real helicopter here. I don't. I don't have a helicopter. Although when I was a kid, I wanted to buy a gyrocopter from the back of a Popular Mechanics magazine, and I thought it'd be so awesome if I could just like fly that to school, or if I could buy a 2-person. All right, here we go. 30-second story. I wanted to get like a 2-person go-kart and a 2-person gyrocopter, and then have like paintball capture the flag wars, and it would have been like real life Halo, where like you would have just like had like one team with a helicopter, and like it would have been awesome. And then like the the go-kart would have been like your Warthog. It would have been so great. Also, probably very dangerous. Like if you shoot a paintball into the intake of a gyrocopter engine, that thing's probably stalling out. People are probably gonna die. Like, not a good idea. But fortunately, video games, you can do all sorts of dangerous things and not bring harm to yourself. So it says the position of a helicopter search and rescue crew is shown on the graph. The shortest flight path to the shoreline is one that is perpendicular to the shoreline. So okay, so imagine, right, here's my water, all right, and here's like, I don't know, here's like a cool dolphin. I would make dolphin sounds, except in SpongeBob's world, that would be bad word number 11. And I don't want to. This is a family-friendly YouTube channel, and we're in a public school, so no bad word number 11. But there's our sweet dolphin. Look at that. He's amazing. And so this helicopter, the shortest distance, I don't know if you guys realize that, but the shortest distance from a point to a line is measured perpendicular to that line. You guys know that? So they want us to write an equation that represents the path the helicopter should take. Like, what if it's running out of fuel? Or what if someone's like, you know, got beat up by dolphins and now you gotta like rescue them, right? And you're like, man, those dolphins are jerks. And this person's like on the brink and you gotta get them to the shore so they can get the help they need. How could I find that out? Well, I know that my blue line, if it's perpendicular to the purple line, will have a slope that is an opposite reciprocal. So what is the slope of the purple line? Well, to do that, I could just pick some points that the purple line crosses the grid. Looks like there and there. And that one would work as well for that one. But I really only need two of them. What's the slope? What's the rise over run? Well, this is going down 2 and over 3. Yeah, so the slope of line purple, the shore line, is negative 2/3. What would I expect the slope of the blue line to be? Positive 3/2. Flip it and change the sign. Opposite reciprocal, negative reciprocal, all sorts of options. And also notice I could actually have tested that from here's one of the points they gave me, here's another point on the line, here's another point on that line, up 3 and over 2, and up 3 and over 2. Perfect. So it appears as though our prediction is correct. Now, we know that the helicopter is presently at 14.4. That will be our x1, y1. And let's plug this into point slope form, friends. Let's rescue some people from dolphin criminals today. All right, just like we do every day. Y minus 4 equals m, which is 3/2, parentheses, x minus 14. All right, let's switch this into slope-intercept form for funsies. Do some distributing. We're not going to lose another life to dolphins. Y minus 4 equals 3/2 x. 3/2 times 14. Okay. Now I could do 14 times 3 and then divide by 2, but 14 times 3 is starting to maybe get out of the range of my multiplication tables, perhaps. I don't know. And so instead, let's do 14 divided by 2 and then multiply by 3. What's 14 divided by 2? 7. And 7 times 3? 21. 7 times 3 is 21. And this 14 was negative, that fraction was positive, so it's a negative outcome. Let's solve for y. Oh yeah, don't worry, bud, you're going to be just okay. Instead of rescuing you, we took the time to do an equation. Don't you fret. Actually, they could probably just have like a calculator that's just like fly this way right now, and it'd be all set. Let's see, 4 and negative 21, their signs are different, so subtract them and take the sign of the more influential. There we go. You're not going to win this time, Dolphins. Sick and tired of your dolphin violence. Can't believe it. But due to perpendicular lines, we will always be victorious. Thanks for watching, Internet friends. Have a great day.